Hello everybody, hope everybody's having a good Tuesday. Kind of off to a rough start here. I was, believe it or not, asleep up until about 45 minutes ago, so I had to scramble to put stuff together and to get the live stream page up. And I don't have a video here because it's dark outside, so there we go. Anyway, yeah, I am on a nighttime schedule because that's when I get most of my programming done, and it's been somewhat of an extreme the past few days. So you've had a chance to look at this current thickness chart. Maybe you've kind of used what we've learned over the past few weeks and placed the front. Well, you can see the thickness gradient is kind of in this area, kind of in a very broad band. And we know that because of that, we're going to find the front on the south side of that thickness band. So we can go ahead and draw that out. Roughly, the front's going to be something like that. It gets a little more indeterminate out in Arizona. Now the question is whether the front is way down in Mexico or still up in Arizona. And to further complicate things, a lot of times in the mountainous terrain, the lower parts of the air mass that are moving south can actually move a lot slower than the parts of the air mass aloft. So some of the frontal passage may be well to the south of the surface front aloft, and that can actually distort the field southward. So what I'm saying is you might have a surface front here and then an upper level front back here. And as a result, you tend to get the thickness gradient across a wide area, kind of like that. Well, let's finish out the rest of this analysis. Again, I don't know I'm not too sure what the picture is over the desert southwest. The rest of the fronts are going to look like that. New system coming on the California coast. There it is right there. Looks a little bit maybe weaker than the last one. And this is likely bringing in some cooler air from the northeast, from Oregon and Washington, heading into the backside of that storm there. Across the Great Plains here, very strong warm air, cold air advection from the north. And you can see that the center of the cold pool is over Saskatchewan and Manitoba. Much of the Midwest, including Indiana and Ohio, getting the wraparound from that northeast U.S. system. So there it is. There's that wraparound. And on the other side, we have our dry slot working into Virginia and the Carolinas. And that's behind the surface cold front. All right. Felix says, storm front arrived in Northern California. Cold and rainy in Northern California, just like Tim said. Yeah, looks like quite a bit of rain there depicted right there on that NAM map, and maybe I can pull up some radar. It's good to see California finally getting a bit of relief here. Let's see. I'm trying to do this without loading GR level 3 because that's going to eat up bandwidth. I'm going to try College DuPage and bring up a radar that way. That's probably going to be the San Francisco radar. Wow, what a mess. That is a pretty good rain there in the San Joaquin Valley, and probably some snow there in the higher elevations of the Sierra Nevadas. And yeah, these look a little bit convective. That little band moving here through the eastern Bay Area towards Stockton. I'll see if I can look at one more radar product, since we don't get a chance to look out that far west very much. We can try, let's see, what can we look at here? I guess we'll, Sorry, I don't really have any good ideas for a product to look at because I know a lot of this is probably liquid. If we had a weather that was a little bit colder, closer to the radar, I think this would be a good opportunity to look at differential reflectivity and hydrometeor classification. So we'll probably wait on our next big winter storm to do that. Across the North Pole, let's look at the temperature anomalies. We haven't done that in a while. And yeah, unfortunately still above normal out on the polar ice pack, and the warmest weather out here around the western high Arctic islands of Canada. What does this above average temperature mean as far as real values? Let's go up and take a look. This is the current weather about just in the last hour, and we can see temperatures in the upper 20s along the north slope of Alaska, 27 there, or actually 30 at Inuvik, almost above freezing. It's kind of weird. You go down south into Canada and you hit much colder air. We go from 30 to minus 17 way down here. But most of the radiation across the ice pack has been pretty strong here. Very good chance for the air mass to build and deepen. And we can probably take a look at the soundings real quick. We'll just take a look at one sounding and see what it looks like in that air mass. We'll try central Manitoba here. That's what it's going to look like in the middle of that cold air mass right there. So it looks like a very cold column here. Actually, the upper part looks a little bit warm. With the coldest air masses, we tend to see the temperature just kind of do this. That's what we would see in an Arctic air mass, something like that. This is more, most of the cold air you can see is concentrated in the lower 750, 800 millibars, but very cold down there at the surface. And let's try one more here. Go to Glasgow. Remember they had problems last night. And this looks a little bit more like a, yeah, this is a little bit more what I was talking about when you get kind of like a very intense Arctic air mass. What you have is the column it'll be almost moist adiabatic all the way up to the tropopause at up about 15 to 20,000, and then you get this huge stratospheric layer above that. So this is almost showing that kind of pattern right there. 500 millibar chart across North America looks like this. See if I can scroll that up a bit. I think that's about as high as I can go there. Jet stream, polar front jet going well to the north, and we expect that with temperatures being in the 30s in Alaska, up in this region. So a lot of the baroclinicity is shifted up to Alaska. So we've got the jet kind of pushing up through that area. The general flow is it coming to the south. So basically we have a big long wave trough here, a large long wave ridge out over the west coast, and embedded in that ridge are these smaller troughs like that. There's another one, there's another major one, and embedded within that you can have smaller scale short waves. And those are the toughest ones to look for. That's where we really need the 500 millibar heights and vorticity to really pick out those smallest waves. And to find those smallest waves, well, here's one of the major ones right here. And we can probably see a couple small waves like that right there using the vorticity patterns. Okay. Let's see. Let's take a look at high temperatures across Texas and the central U.S. 80 degrees there south of Houston. 79 at San Antonio, so a lot of warm air ahead of that front, which is diving down south, and we've got 20s there up in Kansas and Nebraska. Temperatures up north not excessively cold, but that's still pretty frigid. -3 there at Minot, and looks like in the -6 range up in Saskatchewan. All right, let's see. One little bonus thing I can probably give you guys before we go into the forecast. We'll do a little bit of wind grids and look at cross sections. Let me get this window scale down so it fits. Okay, there we go. Then I'm going to open the file that I just downloaded. I've got some NAM data here. Here it is, January 3rd. And there we go. Now it's coming up here. So we'll construct a cross section across the Central Plains. Okay, so we're going to bring a cross section from just off the Texas coast, right there, and then we'll go up to the center of the cold air mass in Saskatchewan. Okay, did I do that right? Yeah, I think I did. Hang on a second, this thing didn't act quite the way I expected. I guess that's correct. Yeah, it took. Okay. And I got a telephone call. Hold on a second. I got to make sure this isn't an emergency. Okay, I'm back. No real problem right there. I was just talking with my kid. He wanted $5 for PayPal to get a video game. So let's see here. Okay, what I've got here is a cross section going from the Gulf of Mexico, right here, going northward. This is going to be Oklahoma right here. This is going to be Nebraska and Dakotas. And then Canada is going to be way over here. These lines are graduated in latitude. Okay, so that's the setup right there. So now I will bring up the products. And there you can see the cold front right there. So Dallas-Fort Worth is going to be located right around here. This chart is for noon today, so I can advance that forward a little bit. Okay, so that's going to be the current data. There's Dallas-Fort Worth, and you can kind of make out that textbook appearance of a frontal surface. And we look for the tightest packing of these potential temperature lines and place the front just above that on the warm side. So even using cross sections and potential temperature, you place it on the warm side of the gradient. Okay, bring that up to midnight, and you can see the front shifting south. So over Oklahoma, which is in this area right here, we can see the frontal boundary. Let me stop it so I can put on the labels. There you go. This adds the vertical coordinates. So 500 millibars is right here. That's 18,000. This is 30,000 feet, and 54,000 feet is about right there. And you can see the jet stream right above this frontal zone. The core of the jet is right here. There's kind of a double core here. But the entire area is sitting right above the frontal gradient right there. And then you can see the lower stratosphere here over the Dakotas. Stratosphere all the way down to about 18 to 20,000 feet. Then it kind of wraps into the transverse circulation around the jet, and then lifts up to higher levels, 30 and 40,000 feet, out over Texas. So that's a pretty textbook example of a deep polar front. Okay, so let's go ahead and set up the forecast. And just say hello to everybody. Got a pretty good crowd on tonight. I appreciate you all joining. And one person said they lost my audio. Hopefully you fixed it there. Sometimes if you reload the webcast, you'll get it working. Okay. Here we go. Here we got the current map, and you can see high pressure across the Dakotas and Montana, pushing that front into the Gulf. A little bit of snow showers across the higher terrain of the Rockies. And let's see, for our webcast tomorrow. There's the changes over the day tomorrow. And what we see is ridging down into the Mississippi Valley, down into the southeast U.S., and we develop this weak warm air advection pattern right here due to cyclogenesis over Colorado. So basically we've got low pressure developing in this area, and there's a response in the wind field that comes from the south. Maybe not at the surface necessarily, it'll probably be kind of easterly at the surface, but just above, like at 850 and 925, it'll be somewhat southerly. And of course that'll develop your isentropic lift and enhance the cloudiness to the east of these lows. And north of there, also some isentropic lifts, so we see heavier showers in the mountains of Colorado, affecting the Overlook Hotel, maybe. Then for our webcast on Thursday, we see the ridge kind of pushing down into the Great Plains, continued cyclogenesis out in New Mexico, and we are seeing the bulk of the cold air making another move southward. Kind of got hung up there for a while, and now the bulk of it moves southward on Friday, and we get this pattern. And one thing that I've noticed is that the GFS has fallen more into line with the Canadian model. You remember yesterday it was showing a kind of a deep low developing around the Texas Panhandle and heavy precip kind of in the Dallas-Fort Worth, Oklahoma City area. GFS has backed away on this and has gone more the route of the Canadian model. So that goes with more of a Gulf Coast system. And it develops down in this area right here, and the isentropic lift kind of focuses on this area. And we developed this band of snow from basically Shreveport through Jackson, Mississippi up to Atlanta. And that's going to be on Friday night. Then a webcast on Saturday, which is usually the slowest webcast day of the year. Pacific system moves pretty far offshore there. Doesn't look like a big nor'easter storm. Pretty quiet across the Central Plains, just a lot of ridging and cold air. Then on Sunday, not much change, but we kind of focus on this area with another Pacific system coming on shore. Monday, we see that come inland, affecting the Great Basin area. And then on Tuesday, moves pretty rapidly to the northeast. And that looks like kind of a weak cold air outbreak right there. Yeah, that's pretty weak. It barely even makes it into Texas. So for Wednesday next week, looking like this. Looks like a new Alberta Clipper coming southward. For Thursday, Alberta Clipper continues moving southeast, and we find it in the Great Lakes area, kind of like that. And looks like another little burst of cold air coming south behind it. And that's what we see with this northwesterly flow, just kind of a succession of air masses moving southeast out of Canada. The next Friday on the 14th, big high pressure moves into the eastern U.S. behind that last outbreak. And then on the weekend, models are going for a central U.S. system affecting Chicago, Milwaukee, Des Moines, and Illinois and Indiana right there. This is the 15th on Sunday. And this is where we start to get pretty far out. Just more cold air coming south. And hopefully with one of these winter systems we can take a look at that radar and kind of focus on dual pole products. That'll definitely be fun to check out. And that brings the webcast to an end. All right. I appreciate you watching as usual. Hopefully by tomorrow I'll be back with the usual videos, time-lapse and stuff like that. Neat clips to look at. Otherwise, I appreciate you joining, and we'll see you tomorrow, guys. Have a good evening.